Okay, so this question, we're going to be solving it in two different ways. They're both essentially the same thing. It's just whatever way makes you the happiest. Now, because this question is given to us in vector line form, which means that what I'm really looking at over here is a vector that can be broken down into a point that we're given plus a constant multiplier multiplying the direction of D. So if I'm thinking about graphically what this looks like, I've got a point over here that we'll call A. So this will be a little vector A going from our origin. And over here, I can say that this is following a vector line. So that's got a direction of D. Now, normally D would be down here with O. But what we're doing up here is if I do the A plus D, that will make our resultant vector like that. Now, if I multiply the D section by some constant multiplier, it means that I'm going to end up with a position along this line. Now, that's significant to us in this point because if I've got two crossing over like that, that means that I want to find the point where these two things share that same value. So I can take the vector equation of this line here and the vector equation of that line there and find out where they have a simultaneous solution. So we're going to solve it in the way that it's given to us, meaning that it's going to stay in vector form. So the first thing that we need to do, L1 is equal to L2. If they're simultaneous, they share a coordinate where all points are going to be the same. So that means your X coordinate, your Y coordinate, your Z coordinate, they're all going to be the same. Or your IJK if we're leaving it in the vector form. So first thing I'm going to do is I'm going to state these two equations. Now I'm going to be lazy and I'm going to lasso them. Okay, so that didn't work. So now I'm going to write them out. Okay, 5i minus 3j minus 7k plus k bracket minus 4i plus j plus 5k is equal to minus 5i plus 2j minus 9k plus k bracket 6i minus 4j plus 7k. Okay, so now I'm going to group my like terms. So this section on the end is all terms of k. So I'm going to move this one over to this side and I'm going to group my other ones, which are all just going to be standard terms. So this one is going to get grouped with this one. So he's going to come over to this side. That's going to make my new equation 5i minus 3j minus 7k minus 5, when it comes over, it will change all the signs. So plus 5i minus 2j plus 9k is going to be equal to k. Now, I'm only going to write the k once. I'll write it twice. You're lucky. Okay, 6i minus 4j plus 7k minus 4i plus j plus 5k. Okay, so that means we've got 10i on this side. Now we've got minus 5j plus 2k is equal to, now when I'm grouping the terms over here, I'm going to leave the k out the front. So the 6 and the 4s, that's going to group to become 10i because this minus will change that symbol there. Minus 5j plus 2k. All right, perfect. Okay, so now I want to figure out the value of k so I can substitute it into one of these equations to find out where that point of intersection is. So all I have to do is take this to the other side. Now it's currently multiplying, which means when it comes across over here, it's going to divide. Now, standardly, you could look at this by doing k is equal to and then divide each term. It's multiplied by a constant, so you should get the same answer for this I term divided by that I term as you would for this one divided by that one. So here, it's the same in both, so k is going to be equal to 1. Okay, so the next thing that we can do is we can substitute it into either of the equation, and that's going to give us the coordinate of intersection. So here, down here, coord innate of intersection. All right, so here we go. Chuck it in. 5i minus 3j minus 7k plus k bracket minus 4i plus j plus 5k. Okay, now that's going to be equal to, now k has taken on the value of 1. So now I can group together my like terms. 5i minus 4 is going to make 1i. The 3 plus the 1 will make minus 2j, and minus 7k plus the 5k is going to make minus 2k. Now, that is the final solution. That is the point where these two lines will cross over in 3 dimensions. But in a lot of times, we might not be given this as a vector equation. We might be given it in Cartesian form or in parametric form, which means we need to know more than one way to solve a question like this. So next thing we're going to do is we're going to look at how we could perform this solution in parametric form. Okay, so our first step to looking at solving this in parametric form is to set these equations up as parametric equations. So in order to do that, all I have to look at is, if I've got my equations, let's go back up, we'll steal them. All right, here we go. If I've got my equations in parametric form, I'm going to first highlight, so it means I'm going to put them all in terms of that extra variable that we've got there. So I'm going to highlight that one because that's kind of like an x term. And then I can highlight this. That is also kind of like an x term. Now, if I keep doing this, you'll see that there is a pattern when I finally put these all together. And this turns out to look pretty sick if I do say so myself. Sometimes in maths, it's just like, hold on to your hats, kids. This is awesome. All right, so over here, when I'm setting up my x equation, x is going to be equal to 5 minus 4k. See that, and it's multiplied by that. Ah, beautiful. Y is equal to minus 3 plus k, because this one has a coefficient of 1. Z equals minus 7 plus 5k. Hot diggity dog, so impressive. Now, L2 is going to be set up in the same way. We're going to have x is equal to minus 5 plus 6k. Then we'll have y is equal to 2 minus 4k. Z is equal to minus 9 plus 7k. All right. So now we've set it up in parametric form, we can start looking at how we're going to solve this parametrically. The first step is to find out that point where of k. There is some constant here that if I multiply both of the functions, they'll share a point of intersection. So all I need to do is take one of them, any of them, whatever one makes you happy. I'm going to go with the x's. So, and we're going to let the x from L1 be equal to the x from L2. So the constant that goes in here to make these two equations the same will be the same constant that goes in there to make these two the same. So it doesn't matter which one you pick, just whatever makes you happiest. Okay, now we can take this to the other side, giving us 10k. I'll take this over here, giving us 10. So k, again, is equal to 1. We found what we found above, just a different way of doing it. Okay, so now I can carry forward with this answer that we've got here. Now, I can chuck it in to this set. So I'll just put this little arrow here, and I'm going to, actually, I won't. Okay, so let k equal 1, and we're going to put that in L1. Okay, and this is going to give us a list for what our x coordinate is, what our y coordinate is, what our z coordinates is. So x is going to be equal to 5 minus 4, which is going to be 1. Y is going to be equal to negative 3 plus 1, which will give me negative 2. And z is going to be equal to negative 7 plus 5 times 1, which is going to give me negative 2. So that leaves me, if you want to set it up, you can write it like this. If you want to have it as a matrix, or you can write it out like this. They all mean the same thing, doesn't really matter. Not that I know of anyway. And that's it. Have fun.